So this is the Integrated Math 2 formative quiz, okay? Giving you information on what you know and what you do not know. Very important topic, quadratics, sections 12.1 to 12.3. Yes? No. Number 1. Okay, this first problem, we are asked to write it in standard form. Here we go. Let me zoom in a little bit here. This is going to be, we've got to distribute here and here. This is going to be 3x squared and then minus 24x plus 5, and there's your standard form. All right? Here's your A, here's your B, and here's your C. Let's move on to number 2. Number 2, if you're going to simplify this problem, what you have to keep in mind is that in order of operations, PEMDAS, you have to simplify the numerator, the denominator, and then you can work with the division. So watch. Let's take this 2n and distribute. This becomes f of n is equal to, well, what is 2n times 3n? 6n squared. And then we have 2n times negative 6 is minus 12n. And then we all divide by 3. Now, this is the part that students usually have an issue with. It's a simple mistake, but let me point this out with an arrow. This 3 has to divide into that term and that term. This becomes the following. I have 2n squared minus 4n. Is that okay? Makes sense? And there's your function in terms of n, f of n. Number 3, the goal here is to write a quadratic function that represents the area. So that's very important. Make sure we're dealing with area. And these are going to be rectangles, so the area is always equal to length times width with any rectangle. All right. It says here, Leah is designing a rectangular quilt. She has 16 feet of piping to finish the quilt around the 3 sides. All right, so let's do this. Please always draw something. It's going to help you visually. We're only dealing with 3 sides, so I'm not going to worry about this side. This side is taken care of. Now, if I give, how about the width? We'll represent that with x. We know that if I add this side together, and this side together, well, how much piping are we dealing with? 16 feet. So if I add these all up, it has to equal 16, right? Okay. Well, one way to do this. Now, there are several ways to do this. You could call this y. And now, x plus y has to add up to 16. I'm going to simplify this a little bit. I have x and x right here. That becomes 2x plus y is equal to 16. Now, here's the abstract part of this. We only want to write a function in terms of x here. Let's just try to write it in terms of x. So what I'm going to do is I'm going to subtract 2x on each side. And now I have that y is equal to 16 minus 2x. So this side right here is 16 minus 2x. Are you okay with that? And doesn't that make intuitive sense? That if you have a total of 16 feet, well, this is going to be 16 minus these two. 16 minus 2x. All right. Now, right in this area here, we're going to do area is equal to length times width, or x times 16 minus 2x, because we only want to deal with x, but we know that y is equal to 16 minus 2x, so we have 16 minus 2x, and they ask for this in standard form, so we have area is equal to x times 16 is 16x, and then x times negative 2x is minus 2x squared. What do you think? Now it's not technically in standard form just yet. We have to actually write this negative 2x squared first. So here we go. Area is equal to negative 2x squared plus 16x. And that will be the final function that represents the area of this quilt and only dealing with 16 feet of piping. What do you think? Does that make sense, guys? Fantastic. Now, I can guarantee you that you can do this next one based on what we did on number 3. It's almost the same. Let's read this carefully. It states here, it says, Pedro is building a rectangular sandbox for the community park. The materials available limit the perimeter of the sandbox to at most 100 feet. Now keep in mind, what's at most mean? Well, 100 is the most amount of perimeter that we can work with here. Very important, draw something. We've got, here's this sandbox. Now, it really doesn't matter what I'm going to label these. X, Y's, W, L, it really doesn't matter at all. I'm going to say, how about this is X, this is Y, and this is Y. What do you think all of those are going to add up to? 100, right? So I have 2X. Let's zoom in. There we go. I have 2X plus 2Y is equal to 100. Remember, in the end, I'm going to have area is equal to length times width. So this is going to be area is equal to X times something. So I want to find out what that Y is in terms of X, right? I want to get this Y all alone. Well, what's the first thing I do? Subtract 2X and subtract 2X. I have now 2Y is equal to 100 minus 2X. And then, finally, get that Y alone by dividing by 2. Okay, once again, I'm going to take this arrow out because this is important. That 2 has to divide into both of these. So finally, we have Y is equal to 50 minus X. And now, folks, look, what goes in here now? Because I know Y is equal to 50 minus X. So what goes in here? Yeah, length times width, or X times 50 minus X. And all we have to do is distribute, write it in standard form. All right, here goes. Area is equal to, I'm going to distribute to this one first so that it's in standard form immediately. We have negative X squared, and then X times 50 is plus 50X. So the question was, what was A, B, and C? Well, A is -1, B is 50, and C is really 0. You don't have to write the 0. But please keep in mind, this 0 is very important when we get to the projectile motion problems where we're launching something. Okay. I'm going to move forward. Let's take a look at 5 and 6. All right. 5 and 6. 5 through 6 says, use your graphing calculator to determine the absolute max. Describe what the X and Y coordinates of this point represent in terms of the problem situation. You're going to have a bunch of these types of problems. You have to explain what it means. And really, it's just a calculator problem. So let me zoom in a little bit. We'll take out the calculator. We have negative and then X squared plus 90X. And really they gave you the entire function to work with here. You really didn't have to do much thinking. They gave you the area in terms of X is equal to negative X squared plus 90, all right? Maybe at some point you might have to come up with that and then answer these questions. But they're starting you off with by giving you the function. So we've got to find, how about first we need to find the absolute maximum of this thing. Well, you know we have to graph it. And if I hit graph up here, I probably have an issue, don't I? I've got to start setting this window. So we'll head to window. And for an x max, I'll just go up to, how about 200? And how about for a y max, let's set it equal to 2,000. And is that going to be enough? Almost, right? That's enough for us. Okay, so we'll go second, trace, maximum, number 4. We have to have a left bound. So I'm going to come back up here. There we go. Notice I'm on the right of the point that I'm seeking, so I've got to move over. There we go. How about that? That's a little easier to see. Hit enter. Then I'll get over onto the right, right bound. There we go. That's enough. There it is. There's your maximum. 45, comma, 2025. 45, comma, 2025. All right. Keep in mind, here's your x and here's your y coordinate. I want to go ahead and grab this graph. Let's pull this on here. All right. Let's shrink this down and stick it right over here. Some space. So we're talking about this maximum up here. So the x-coordinate of 45, what does that represent? Well, isn't that the... Yeah, that's going to be the width. Because if you travel this way on this x-axis, this is your width, and this is going to be your area. So the 45 represents the width for the greatest area. Okay. Now the y-coordinate, 2025, that represents the greatest area, correct? The maximum area. All right. So it's really just a calculator problem. Okay, how to work your calculator finding a maximum. Let's go ahead and let's do number 6 together. All right. Now, okay, if you're watching this video after for maybe studying or something, there are going to be times when we're going to take this this entire thing. We're not going to give you the equation at all, and you will have to come up with it. So as I read through this, there are some important pieces here. It says a football is thrown upward from a height of 6 feet. The 6 feet is very important. That 6 feet is your initial, so h sub 0. With initial velocity of 65 feet per second. Well, that 65 feet per second is your initial velocity. And that would be v sub 0. Let t represents the time in seconds after the football is thrown, and let h equal the height of the football. Okay, it says the quadratic function below represents the height of this. So let me move this out of the way. In this case, we're going to give it to you. There it is. Now, how would you get that if I didn't give it to you, right? This is how. We have this very important function, h of t is equal to negative 16 t squared plus v sub 0 t plus h sub 0. This is something you're going to be given. And all you have to do is plug in the important information. All right. Look at the 6. Since 6 is h sub 0, 6 is going to go right there. See it? Since 65 is v sub 0, 65 is going to go right there. And you can see, isn't that truly what they've done? Okay, they've kind of given it to you. All right, let's go ahead and graph this thing. Now keep in mind, we're throwing a football, so it's not going to go that high. Well, let's begin by trying to graph this. All right. Head over to y equals. Let's clear that out. We have negative 16. And instead of t, we're going to type in x. So we've got x squared. And then plus 65x. And then plus 6. All right. Let's just come up with a reasonable. Now, I kind of know what to plug in here, but help me out a little bit. Let's think of, you're throwing a football in here. So let's think about what your variables here represent. Your independent variable. Independent variable is t. And that would be what again? What does that represent? Time in seconds. Have you ever thrown a ball and had it hang in the air for like 200 seconds? Yes. You have, Mark? Fantastic. Sign you up. And how about the height? Now, are you going to throw a football a height of 500 yards? Probably not. So let's be realistic in our window here. X max. Now the X max, do you think X is going to represent height or time? Time. It's your independent variable. So let's do, how about, let's just do 20 so we can see a bunch of the graph here in seconds. Let's head down to Y max. Now this is the height. Give me a reasonable number. 100? Fine, 100. Let's graph this and let's see if it makes sense. Yeah, that's reasonable. Now I can even do this. That window, I have an X minimum up here. Let's just make this 0 for now. There we go. Now I didn't need to go up to 20 seconds, did I? I can narrow that down by hitting window. And let's make the X max be 10 instead. There, that's a little better. Okay. Let's start to think about what they want here. They want the maximum. So, second, trace the maximum, number 4. You'll notice, oh, okay. I need to make sure that you see this. I am tracing along this somewhere. I don't know. I have no idea where I am. Can someone help me? Where am I? It's there somewhere. Okay, yes?
You're out of the window.
I'm out of the window. Which way should I go? Left or right? See the cursor. Left. Good. So I'm going to go left, and it's going to. And we know that because, see right here? I'm at x equals 5, so 5, comma, something. It's way down here somewhere. All right, let's continue to come up. We'll start to see it soon. There it is. Now we need a left bound. I need to get to the left of this point I'm seeking. Right there is fine. Enter. Right bound. Enter. Enter. Okay, maximum is 2.03 approximately. 2.03. And then 72.01. All right. Yes?
I did the same thing, and then after I did the 2.
So on a tester quiz, the question was, what if I'm off by a decimal or 2? Well, you should not be off, because if we're going to round to the nearest hundredth, this would be 2.03. And then this 72.02, we've got to think about what these represent here, right? Okay, so start to think about that. Lucas?
Well, on the instructions, they didn't say it was round 2.
Okay, that's totally fine right here. Totally fine. It's just up to you. Okay, in this type of problem. But on a tester quiz, we will be very specific in where we're going to round. Let's get this out of the way. Bring this down a little bit. I have a maximum of approximately 2.03, comma, 72.02. The 2.03, what does that represent? Very important here with respect to the problem. Not the speed. The time it takes this this football to reach its maximum. Good. So it represents the time. Time it takes for the football to reach its maximum height. I'll just leave it at max, running out of space there. How about the y coordinate, this 72.02? What do you think that represents? The height, that's the maximum height, and we would try to be as specific as possible. If this were a test or quiz, I would like to use units up there. So this 72.02, this would represent the maximum height in feet in this one, yeah. So in this video right now, I'm going to do 9 and 10, then we'll go back to 7 and 8. For 9 and 10, all right, let me slow down here to read some instructions. It says, calculate the first and second differences for each table of values. Describe the type of function represented by the table. Okay, let's find the first differences. Here, I've got to find a difference, and you know difference. What do you think? Is this addition, multiplication, division, subtraction? Subtraction, right? So we have right here, it doesn't matter in the order. I could do negative 27 minus negative 48, or negative 48 minus negative 27. It does not matter here. So I'll do negative, how about 27 minus a negative 48. Okay, help me out here. What is that? Yep, negative 27 plus 48, and what is that? Here. Here you go. If you're having trouble with that, you're going to have your calculator out, right? So we'll go negative 27 plus your 48, and that's going to be 21. Okay, so I'll write that right here. That's 21. All right, so we did negative 27 minus negative 48. We're going to continue that same thing. Let's do negative 12 minus negative 27. What do you think that's going to be? What's that? 15? Okay. Let's do negative 3 minus negative 12. Okay, that's going to be 9. Okay. And 0 minus negative 3. 3. All right, so let me get this out. Go ahead and just highlight these. These are the ones we're working with here. This first column just dealt with first differences. You take your y coordinates and find the first differences. Now, if you watch that video very carefully, there is something about these x coordinates that must be true in order for this to work. Does anyone know? If you watched carefully last week, these x coordinates have to be... No, not negative.
What's it called?
What? Not the same.
They have a common denominator.
No. Okay, in order to find first differences, all right, in order to find first differences, this is what happens. These x values have to be consecutive. Do you agree that they are consecutive? 0, then negative 1, negative 2, negative 3, negative 4. You cannot do this. You could not find first differences if it read 0, negative 1, negative 5, negative 16, negative 20. They have to be consecutive, one after another, yes? Makes sense? All right, and it works out in this case. Okay, let's find second differences. Let's do 15 minus 21. For the next one, we'll do 9 minus 15. And for the next one, we'll do 3 minus 9. Okay, help me out. What's 15 minus 21? Negative 6. Okay, next one. What is 9 minus 15? And then 3 minus 9? Negative 6. Okay. Please tell me, what kind of function is this, folks? It is a quadratic. Okay, Lucas, I just heard that, and I want to repeat it, even for the video right now. That's very important. Okay, so here goes. You just said the following.
Quadratic functions have second differences that equal each other.
Yes, second differences that are pretty much constant. What are we talking about? You want to follow this video? See how these are all -6? We say that the second differences are constant, meaning,
That's the word you say.
yeah, they're all the same. Okay? If the second differences are all the same, you have yourself a quadratic function. And I will say right here in my explanation, the second differences are constant. If you put the same, totally fine. All right? Hey, let's look at the next table of differences. All right, please follow me here and answer this question out loud. It's fine with me. Yes?
Does it matter which way you subtract them?
It does not at all. It doesn't matter in the order that you subtract them. If we subtracted them the opposite way here in this first example, number 9, we would just get 6 instead. And they're all the same, therefore it's still a quadratic. Okay? All right, please tell me, are these consecutive? Yes, they are. They're not skipping any values on consider if you were to draw a number line. They are all consecutive. Yes. All right, let's finish this off here. We've got first differences. Let's do, how about 10 minus 8 is 2. 8 minus 6 is 2. 6 minus 4 is 2. And 4 minus 2 is 2. I hope you realize here we have that these first differences are all constant. And then if we do the second differences, look, what is 2 minus 2? 0. Then 2 minus 2, 0. And finally 2 minus 2, 0. If this happens, then this table represents what type of function? Linear function. And the explanation would be first differences are constant. So there was just a question, and I believe I'm going to answer this question correctly here. I think the question was, if you're going to compare quadratic and linear, let me open this right up. There we go. Then for a linear function, first differences are the same, second differences are 0. Now for a quadratic, first differences are different. They're all different values. Second differences are constant. What do you think the third differences are? 0. You see it now? We just didn't expand it one more column.
So it's like once it becomes 0, then it's like the 1 before.
Correct. Correct. And what you can do is this. You can do this. Let me ask you this question. If you're listening to the video, listen also. What is the degree? What I mean by degree is the largest exponent for a quadratic. Quadratic. Squared, right? Look, when do you have the constants? The second differences.
Oh.
Squared, there's your degree. Now look over here. Look at the, this is linear. What is the degree of a linear?
First. So it's
The
like
first differences are constant.
the differences are the same, or is the exponent.
Is the exponent, is the degree, it's the largest.
So that's how they kind of blend. Right?
Yes. I hope that makes sense to you.
Oh, yeah. I clearly know.
All right, as I stated earlier, we're going to finish number 7 and then 8. Let me zoom in. All right, for number 7, it says the first differences for a linear function are always constant or the same, yes. Okay, this one. The second differences for a linear function are always 0. Great, yes, yes, yes. Let's take a look at number 8 here. The first differences for a quadratic function are always different. And the second difference is, for a quadratic function are always constant, the same. I do not mind if you write the same. It's fine. Let's move on. Let's move forward here. We have some terms to fill in. These are very important. Okay. It says a blank is defined as a set of real numbers between two given numbers. Interval. Okay. Next, the x-intercepts of a graph of a quadratic function are also called the zeros. Yes, zeros. And blank AB describes the set of all numbers between A and B, but not including A or B. So it's not including because you see parentheses. Parentheses do not include. So what is this? It's an open interval. If it's closed, then it includes those endpoints. Okay, it's inclusive. And then this one is not. Yes?
I'd just like to point out for the test that you put and you didn't put like the parentheses around the end, so like
Yeah.
if you were using grammar, then you would know that it has to be
Yes. This was a give me, wasn't it? I used the word and here. So, an open interval. All right. It says here, and this one is also a kind of giveaway. We have a blank or a blank, and notice, parenthesis and a bracket. Parenthesis bracket describes the set of all numbers between A and B, including B, but not including A. Those are half closed interval and half open interval. So, all right. Half open, right? And half closed. E states here a quadratic equation that models the height of an object is at a given time is a vertical motion. Yes. Now, keep in mind, a lot of students kind of, as you move throughout integrated 2, integrated 3, think of this word model. You're modeling in a real-life situation, but that model is really an equation. That's what that is. It's an equation that models the problem situation. For this next one, it says we've got a blank, which is, and we have, instead of parentheses, these are brackets. What do we call that? Closed interval. It's closed because it is inclusive. It includes the ends, A and B. So this is a closed interval. Moving on to the next page. I cannot tell you how important these are. This next one is very important. Extremely. So let's see how you did. Let's go through this a little slow here.
Hey, Mark.
For this problem, it says we're going to have to graph the function that represents this problem situation. We need to identify all of these important characteristics. We've got absolute max, the zeros, the domain, the range, and the intervals of increase and decrease of this function. So here we go. Reading this problem. Follow along here. It says a baseball is thrown into the air from a height of 5 feet with an initial vertical velocity of 15 feet per second. I'm going to highlight both of those are very important. So we've got 15 feet per second, and we have 5 feet is our initial height. So let's start to write this. I have h at t is equal to negative 16t squared plus, what comes next? 15, or 15t, right, in this case? Okay, 15t. That's your initial velocity plus 5. Very good. Very good. Now, watch what I'm about to do, and I'm going to use some fading ink, and you tell me which one is probably going to be closer to the graph of this thing. So here's some fading ink for you. Let's first use purple. That one, or maybe something like this. Purple or pink? Pink, because this baseball, is it being thrown from the ground or from an initial height? Oh, yeah, we've got initial height, so it's going to be the pink one. All right. Well, let's go ahead and take out the calculator. And let's clear all of this out. Open up the large viewing screen for you. And here we go. We have negative 16x squared. And we have plus 15x plus 5. Now, this probably is okay to leave it with the window that we had earlier, right? We've got an x max of 10 and a y max of 100. We're still launching some sort of ball up into the air. We'll adjust if we have to, but let's graph, let's see. Okay, what happened there?
Window.
I've got to adjust my window. Go. Window. We've got a y max of 100. Let's bring this down to how about 20?
Wait, you did the wrong one. You did the YCL.
All right.
YMCA.
Let's try that again. Y max, let's go 20. Let's change that Y scale back to 1. And now we'll graph. That's a little better, but still. Okay. Let's change this again so it's a little easier to view. I'm going to go X max of how about 4. Let's go Y max of, let's say, 10 and see what that does for us. A little better? Okay. All right, we've got to get a maximum. Here goes. Second, trace. Maximum, number 4. And it's asked for a left bound. I've got to come back up. Come in here somewhere. There we are. All right, enter. There's my left bound. Let's get to the right of the point I'm seeking. So it looks like we have 0.47 and then 8.52. So 0.47, comma, 8.52. Okay. So this next question is interesting. It's asking us for the zeros. Now, we come back over here and let's view the large LCD for a moment. I only see one x-intercept. Where's the other one? It's on the other side, but does this other x-intercept have anything to do with this real-life problem? No, because there's no such thing as negative time. We're only going to worry about this one. And the steps here are, second, trace. What are we looking for? Number 2, 0. We did a left bound. Let's head over to the point we're seeking. Get a little closer. And there we have it. Now, here, this is very strange, isn't it? This is the calculator's way of writing this in scientific notation. This means negative 1 times 10 to the negative 12. That is 0.000000000000001. So that's very close to 0. Yes. So we've got approximately 1.2 comma 0. 1.2 comma 0. Hey, do you guys know what that 0 really means? What does that mean? If you were to put some information here on what this represents, this 1.2 means? Logan?
After 1.2 seconds, the ball will be on the ground.
Yes, after 1.2 seconds, the ball is going to return to the ground after it's been like thrown up in the air. Okay? That's not bad. Yes?
Would we be marked down to go to the other X and step 2?
No, you would not at all. You would not at all. It's probably important that I find the other one right now just so that you can see it. And let me get to the other window and we can see that a little bit larger. I need to change my X-min. Let's go with negative, how about -4? And then we can graph this thing. There it is. I want to find the other 0, second trace. Second trace. We're going to find the 0, number 2. We need to head to the left of the point I'm seeking, enter, and then to the right. That is -0.26, 0. So this would be -0.26, 0. And that one really would not make sense as far as this contextual situation, in context of the problem. Domain. All right. Okay, domain. You have to be careful. So you ready? For the domain, you have to think of the two directions, left and right. Okay, left and right. I really slowed down because this is an issue for many students. I'm going to hit the trace button, and I want you to just watch this for a moment, and I want you to watch the X values. Now I'm going to the left. You can see that I'm pushing to the left. Is that X value, is it getting smaller or larger?
Smaller.
Smaller. Do you think I could stand here and hit that button for forever and ever? Yeah. I could, and it would keep going. It would go all the way out to what? Negative infinity. Now, I could go to the right. This thing is going to come up. Here it comes. There it is. And I could go to the right. Now, keep in mind, if I'm going to the right, which one of these am I going to focus on, Y or X? X. Do you agree that I could keep pressing this right button forever and ever? Yes. So it's going to go way out to positive infinity. Now we have this certain notation we call interval notation that we're going to describe domain and range with. All right. Here's your domain. I believe that you know it's negative infinity all the way to infinity, but I'm missing something very important. Should I surround this with brackets or parentheses? Parentheses. And the reason being, is there any definite end to infinity? No, it goes on and on. So you can't include it if there's no definite end. So whenever there's positive or negative infinity, enclose it with open or close with parentheses. Range. Okay, range is important here. Yes, it also means all real numbers. For all real numbers. We have a bunch of different ways to actually write this. In our former Algebra 2 class, we would use set notation. But here we're going to keep this easy. If you write all real numbers, you're going to be fine on a test or quiz. If you write the words all real numbers. Okay? Unless it asks you specifically to use interval notation. Let's talk about the range. Okay, your range. The range, you think of the directions up and down. So let's get a larger picture of this. I'm still tracing. Hey, what's the highest how high up does this go? How high up?
8.52.
8.52? How did we know that?
Maximum.
Wasn't that the maximum we found? Okay, so you're saying that this thing goes up to 8.52, but can it go down forever? Yeah. It can. Now, we always start from low to high. Do you think that would be from the max down to the lowest, or from the lowest up to the max? Start from low to high. Lowest all the way up to the max. So here's what we're going to do. This range would be from negative infinity. Okay, before negative infinity, should this be a bracket or should it be parentheses? Parentheses all the way up to 8.52, approximately, right? And what's that going to be? Brackets. Okay, yes?
Couldn't you also say that y is less than equal to 8.52?
Yes, that's another way of doing it. Or y is less than or equal to approximately 8.52. Good. Good, good. Now, I don't believe that you've seen this yet. I actually added this in. It's a little different than the book actually asks. It says here, the interval of contextual increase. That means only give the interval of increase based on the real life scenario. Where is this thing increasing? And we only worry about left and right, only the x values. So let's take out the large graph. And I'm going to start here. Do you agree that this is the only portion, like over here, this doesn't matter at all. That's not important. So we start here, and what x value is this? 0, and then it goes up, 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 up. This is a baseball again. It comes back down, and it drops on the ground. Is this important? Contextual, as far as real life situation? No. So the interval of contextual increase would be from here. It's increasing all the way up to there. Do you agree?
Yes.
Okay. Now think. We're going to describe this. Don't use your y values. We use the x values. So from 0 all the way to, what was that? Not 8.52. All right, let's do this again. I'm going to find the max. Second trace. Find the maximum. This is really important. This is something that causes a lot of issues usually. There we go. All right, let's get this so you can see my the mouse again. So we start at 0 and then we go all the way up to here. What is the interval? It's only using this little portion right here, right? Right there. So what is it? 0 all the way to
0.47.
0.47. 0 all the way to 0.47 is the increase interval. Okay, so we have 0 all the way up to 0.47. All right. And I do want to say, let me get rid of this. That is going to be a parenthesis. Can anyone figure out why in the world is this going to be a parenthesis? Is it increasing or decreasing at this 0.47? Or is it right at the top and ready to drop down? Yeah, so it's neither increasing nor decreasing at that maximum. And technically in calculus it's going to be constant. Okay?
We started from
This next one, interval of decrease. Well, that's going to decrease from 0.47, right? That's up at the top, all the way down to, oh, good, it's 1.2 because that's our 0, 1.2. Anyone having any issues with that? Yes. 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 Very good. Fine. So we write 0 there because our initial height is from the ground, right? 0. I hope that makes sense. All right, so you guys are going to have to give me a moment. I'm going to graph this. So for this one, I'm going to set my y max, how about to 100? See if that covers it. Yes, totally fine. All right, I'm going to find our maximum, number 4. There it is. That happens to be 1.87. 1.88 rather. Yep. No, 1.87.
So you're 1.875.
So your absolute maximum is 1.87, comma, approximately 56.25.
They rounded it in my calculator. It said 1. It says in my calculator. It says 1.87500007.
Oh wow. Well, approximate. We're both okay.
Okay.
Interesting. Okay, next one is zeros. Okay. Okay. One of these zeros on this one is extremely easy to find. And it's basically right here. What is that? 0. It's, that x-intercept is 0, comma 0. Yes. So we've got 0, comma 0. And we also have, well, let's go ahead and find this. Open this up for you. Second trace, number 2 is a 0. All right, let's head down a little bit. Let's get a right bound. 3.75, comma 0. Domain. What is your whole domain as far as the entire math? It's all real numbers. Yeah, all real numbers. So I can write that here. All real numbers. Okay. Now, there's another way of writing this. I'm going to state it in the video just if you want to know. You could write this in set notation, but we'll make it a little easier. X is equal to, this is the symbol for all reals. It's kind of a double R. Okay, all real numbers. Range. Guys, where's the range? Does this thing go up forever or down forever? Yeah, down. I mean, not contextually, right? But it does go down if we're just looking at the math problem. So this would be from, now when we're talking about this whole range idea, if you were to use interval notation, you'd go low to high. Or you could just write here that y has to be less than or equal to, good, 56.25. That's the maximum height of this model rocket. Interval of contextual increase. Okay, pull this down here and let's create some space on here for you to see. I'm going to use 2 highlighters. We'll go yellow and green. Get a smaller one, this yellow one. That yellow, would that represent the interval of increase or decrease? Increase. Now, what would that interval be using interval notation? Well, parentheses from 0 all the way up to 1.87. Parenthesis or bracket? Parenthesis. We're not going to include that point because it's not increasing or decreasing right at the top. So parenthesis. There's my interval of increase. Now, where is my interval of decrease? Well, let's change up the color here. There we go. That's going to be my where it's decreasing, or it's going downward. So that would be from 1.87 all the way out to 3.75. Yes. So we've got 1.87, and that's because this point right here is 1.87, comma 56.25, and this point right here is 3.75, comma 0. So it's going to be from this to this. good. Next ones. We're almost done this. Number 14 says all real numbers that are greater than or equal to negative 100. We have to use interval notation. Now, please, this might help some of you. I don't want to see mistakes on this on a test or quiz because these are gimme points. These are free points. So if it helps, draw yourself a number line. This number 14 indicates all real numbers that are greater than or equal to negative 100. Put a negative 100 here. Is this including negative 100 or not including? Including, so we're going to use a bracket and it's going to continue to the right. So now we need to write this interval notation. This is going to be from negative 100, bracket, all the way to infinity, bracket or parenthesis? Parenthesis, very good. Okay, next one. Next one, I have a negative 36 and a 14. If it helps, here's your negative 36. Here's your 14. And this one is a less than or equal to. Whenever you see less than or equal to, does that indicate parenthesis or bracket? Bracket. So we have all real numbers that are greater than 36, but less than or equal to. Yeah, so, well, actually it says here greater than negative 36, but then less than or equal to 14. So we might have parentheses and brackets happening. So greater than 36. That's going to be parenthesis, then bracket. Negative 36, parenthesis, all the way to 14, bracket. Really, they're testing you on whether to use a parenthesis or a bracket. Next one, all real numbers less than or equal to b. If it helps, draw a number line. If this were b, right there, less than or equal to it. So we're going to be less than or equal to bracket and all the way to the left. Okay, this is interesting. What do I start with? Always low to high, so negative infinity with a parenthesis all the way out to b bracket.